1,280 feet. So when I've got that scale of 1 to 2,000, I said that incorrectly. I used my 20 side, I add my zeros, right? You guys are measuring 5.28. Well, what are we going to do? We got 3 zeros. 1, 2, 3. That's where it goes. Remember your civil stuff from way back in drafting 131? That's why these maps are so well thought of and used, because we can pull out an engineering scale and we can get very quick measurements off of these things. Now, how accurate are you going to be when you're measuring to this scale? Okay. At some point in time, we've got to leave these and we've got to go to the site and do a physical survey to get down to the negative inch, negative foot, or whatever the design calls for. Yes?
I'm confused. So why does it have a mile and a mile? I mean, why does it have, it's not,
Okay,
it's not 1 mile.
all scales are mostly just graduated that you put on a drawing. And this is the next page in your text, by the way. What we do is we have the unit of measure, the big unit, 1 mile. Okay. Then we go ahead and graduate that down. It'll be on the left or right. You see all different kinds of styles. In fact, if you look in your book on the next page, I won't pull mine up because I'm going to use the map. Okay. You see a bunch of those different map scales. Now what we do then is we break it down into increments that are even to this portion. Because if I get partial miles, I need to be able to kind of estimate where that's at. Now these are meant for being used with the map in the field, because that's where these maps end up. How many of you, well, I don't know if any of you have, but if you work with a field crew, where are your drawings at? When we did our tours, where were the drawings at when we walked through the houses?
On the floor.
Right there, everybody sees.
Laying on the floor, right? Had they been rained on? Have they been stepped on?
Lunch drop
Okay.
on
Yeah, I think Wolverton probably had the best solution where they laminated them, like some of you have laminated maps here, okay, to kind of try and retain that. Are those maps the same size as when they were printed?
No.
Absolutely not. Humidity has got to them, sun's got to them, cold, heat. They've changed shape. What is this scale that's printed on the map? What does it do if this paper changes shape?
changes with it.
It changes with it. What if you run it through a copier and scale it? Does a copier scale at 1 to 1? Says it does, but it doesn't. So this is a great idea where we put the scale right on the map. So if somebody goes out and says, oh, you know what, I'm out here, and they rip the thing in half and go use the part that they want, or it sits on the bottom of a truck and people are stomping on it, they can still pull it out and use it. So we've got just units. Now, we generally don't go down past what we think the scale factor is. Like this one goes to the nearest 1/10 of a mile, right? Because I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can estimate in here also, somewhat. But it's really only accurate down to about 1/10 of a mile, okay, which is about what, 52 feet? Okay, somewhere in that range. Which kind of brings us to the thought, are these maps accurate or are they precise? What are they?
Accurate.
Yeah, what do the two terms mean? You nailed it, kind of threw out they are accurate, they're not precise.
Ballpark, pretty close. I mean, as close as we can get.
Okay?
And precise is just dead on.
Yeah, that's a pretty good way to say it. Accurate is an average measurement. I think is another one. Precise is a repeatable, exact measurement. And I don't know, maybe I can put it in terms, a lot of you folks are shooters here, right? It's kind of how I've always thought about this. Okay. Let's put we're sitting there sighting in a rifle. Okay. So you go ahead and pull up and you start burning some powder and sending stuff down range. One, hits like this, one hits like this. One of these is precise, one's accurate. Which one's precise? This one's precise. Now, it's repeatable, and it has a very small margin of error. But it's not anywhere around the center. So you might be precisely right, or you might be precisely wrong consistently. What is accurate? Accurate's kind of the average, right? That's this one. Here you're accurate. What we really need to do, this map gets you accurate. We've now got to go to the field, do an on-site survey so that we can get precise, and we need to blend these two together. So when we're looking at that scope, there's our pattern. That's what we really need to do. We have, with today's capabilities, to virtually be perfect on our designs in the office. You do need to understand when it goes to the field, it will not be precise. There are inherent errors in our measuring devices out in the field. So if something's a 1/4 inch off out in the field, don't throw a tizzy. Okay? That's just going to be the error. Now, in our office, we have the potential to be perfect. We do. So we want to make sure that we are following that, okay, or trying our best to maintain it. Everybody, if they all work to their capabilities, we end up with the best design possible, the best built item possible. So keep in mind where you're starting with. You're starting with a global map, then you're going to an on-site survey, and then you are putting your design and taking it back out. Some other things about this map. Notice that there is a declination on most of them. This declination listed is the declination at the time the map was made. Okay, we real quickly hit that the other day. So if you're using this, and north is to the top, okay, then you would then have to take it and go ahead and rotate by this declination, but then you would have to rotate back due to the declination of today once you took it to the field. So you got to convert the two declinations to get this accurate. Now there's a lot more to this, but I do want to go over one other thing. So here are a bunch of graduated scales. They're styles that you see out there quite frequently that go with maps, and we will put these on our maps. Again, I'll demo how to draw one of these. In essence, you just draw them true size and model space, and then they scale to the viewport. They're not hard to make. A little bit of hatching, and you can knock these out fairly quickly. The trick down here is a lot like what you used with the Trammell method. Remember when you made your ellipse or the sketching of a circle? This is really kind of how you want to use this, and why the scale is another reason why the scale is. So if I take an item like this map, and on mine, notice on the top here, I have this kind of, let me kind of zoom in on this. Okay. So I have this little double hidden line right here. Does anybody know what that represents?
The trailer.
Yeah,
Non,
yeah, trail.
Well, if you didn't know, where could you find out what that means?
go back to the notes from yesterday and see what it says.
Your symbology for topographical maps. This is an unimproved dirt road.
That's what I'm unapproved.
Okay, so it's not a hard top. Okay, so it's some dirt mining road or something like that. Okay, now if I had to do a little design and I wanted to know the distance, and let's say I was going from the Langer Monument right here, okay, and I wanted to come over to where I cross, I don't know, some contour. What I would do is I would basically take a piece of paper, and I'm gonna make my little start right there. And then I can put this and follow, am I still on there?
Yeah?
Okay, so you can see it? So I basically try and take out the curve. So I take it and say I'm going right to there, and then I realign on that position. That's gonna get me to there. And then I can take that, that's to the apex. To there. And let's just say, I'll kind of cut this off. So you get the idea. Now, in essence, what I've now done is I've taken that curved feature and I've changed it to a linear device from here to here, right? By doing those marks and moving this piece of paper. I can then take this right down to my graduated scale and figure out how much that was. Okay, so I just measured off 1, 2, 3, about 3.75 miles. So 0.375 miles. Or I could take my 20 scale and measure this and get the feet exactly.
What was that method called again, Chuck? That method of doing that, what's that called?
Well, when we did the ellipse, they called it the Trammell method.
Trammell, yeah.
I call this the piece of scratch paper method. Okay. In essence, by making those marks, you take these curved features and you're, in essence, pulling them out straight, right? So that you can accurately measure them. Now, they do make other devices like wheeled things you can put on here and follow that. They're really hard to use. They're not as accurate as this. Okay. So if you're using these, it's a good way to do it. You want to give that a try real quick? Just make sure you can do it. Grab some linear feature if you're working with a partner. One of you do it and see what you get. Just grab any piece of scratch paper. Pick yourself a start spot.
You got better eyes here.
If you have any questions while you're doing this, raise your hand and I'll come over and kind of help you.
We're gonna do it, you have this, go from this point? We wanna go from this point around to here. Here. I'm going from this point.
Belton Creek.
So down.
Great country.
That's pointed at.
Oh, here?
Yeah.
I used to do this all the time,
Did you?
because we traveled a lot and you're using, just got the atlas, so.
Like
that?
It
It
is.
Yeah, the old road maps you bet we used to use.
Right here?
The same people our age, this kind of naturally.
Here, go for it.
It's younger folks, probably first time
Okay,
they've seen it.
sorry. Oh, here you go. And then you go like, I mean, I think about computers and say, okay, you know, how things are here. And I try to tell our kids and they just.
Then you go like that, and say, okay, I'm gonna go to.
But you know, even back then, there were people who
Then you go like that.
would follow maps and understand maps and people.
And then you go here, and then you go to.
Okay.
And now you're measuring from here to here. Now you're going like that, right? You go from the zeros, you go from zero, right? From 1 mile, probably this is the scale of that, right? So what's that? So here's half a mile, so we're 1, 2, 3, 4, 10, 4.2 miles? Let's see if we have a check. Oh, yeah. Feet. So divide the miles by that, right? 5, 2, 8,
So you try and keep your start point constant, right?
What's that?
You try and keep your start point constant and move it
No.
around.
No, you can't keep it constant.
Was that pretty much on?
Yeah, you were.
My daughter is, has
So go ahead and put it on my one chart.
Okay, so,
She's got her hair dyed.
Now, try and keep that mark on your start and rotate.
I told you
So
that
that's
there was
four,
one
right?
here,
so
no,
this is,
I'm like that.
You're just trying to get as much of a linear section. So it might be more
So this is
here.
her north.
Now keep that
And
one.
the lighting's
Rotate
looking at
it
her.
over.
This
Charles,
is-
let's see.
Straight that way on it. Okay, so that's
wait, how would you say that? It's not 200 miles. It is
A lot of times you do is.
1, 2, 3, 4.
Oh
Oh my
That
God.
way you see.
Whose is that?
Okay.
My
I
daughter.
thought you were trying to keep that one.
She's doing the Little Mermaid.
And then you would
She
measure
can't,
that
she's
little
playing
curve
everything.
and you're always.
Is that a real
The
dog?
last mark you need is the part you're trying to keep soft.
Okay.
She looks just like
That
her.
makes
Yeah?
Taking that one, but doing that and pulling it straight.
That's impressive.
Yeah.
Yeah.
Okay.
Come on, am I right?
Well,
Did
see
you do
how
a
it
May
goes.
where?
At the Orpheum this weekend.
It's the Orpheum.
It's the downtown theater. It's the old one on Main Street. So it's Thursday, Friday, Saturday.
Maybe I'll go Thursday.
One Thursday and Saturday.
Oh,
My
that's
parents are
pretty.
coming.
Is this for school or is it for?
How much are tickets?
Yeah.
I think they start at $10.
Really? Okay, I'll probably go on Thursday. I have nothing else to do, other than go for a round in the first.
And you measure this way.
All right, yeah.
Yeah, my friends, the one.
That one. Now, I need this.
Right on the mark.
Yeah.
3/10. Yeah.
0.6 miles.
Come in and I'll say, you know, there's my mark.
This is my daughter. She got her hair. Little Mermaid.
Oh,
So that's this weekend.
oh, nice.
She got her
Is,
hair.
like,
She's playing everything.
how fun, oh my gosh, she must have a beautiful voice.
But a real effective. Yeah, get it quick, accurate measure.
Oh, that would be fun.
Yeah. And
Center on this one.
she knows her
It's
parts.
nice.
So it's gonna be yours. Get her.
Is that today?
It starts Thursday.
Should I stop
It's
at
at
the
the Orpheum.
Oh, it's at the Orpheum. Oh, that's fun.
That's what I-
Oh, yeah. Oh, so who's playing it on?
I'm almost done with this.
Oh, it is for school. Okay.
Oh, she
That's me.
Is that the thing we're just